Today? Good. How's BriForum going? Excellent. Good turnout. We had different predictions. Torsten said we might only have 3 people because we did a 2-session thing, so it's great to see a good turnout. Thanks for coming out for this session. It's an interesting session because none of us started off as storage guys, and we'll get into that. I'm Steve Greenberg. This is Joe Shonk, and our third presenter, relatively unplanned, is Hal Lang.
Yeah, we do have higher. I mean, we don't have a stage this year, so they might not be able to see.
Can everyone see me? No? All right, hold on.
Okay, we can hear you though. We work together out of Scottsdale, Arizona with Thin Client Computing. We've been in the server-based computing virtualization space for a long time. We're originally early Citrix guys and moved into VDI and are known for various projects and technology innovations. The session abstract, can you see him now?
They said they couldn't see me. So.
Okay, you can definitely see him now. Session abstract covers storage terminology, getting some basic concepts like block and file storage, talking about hypervisors, virtualization applications, and then we get into some other sizing examples and best practices. We did do a version of this session last year, and it definitely didn't fit into one, so we split it into 2. So I took the more basic one, and Joe Shonk's going to take the more advanced one, which is the session that follows this in the same room. Okay, so why this session? I said that we started off, we weren't really storage guys in the early days, and the first thing is like, isn't storage boring? And historically, we always thought like, oh, who's the storage guy? What does he do? Just give me some storage, let me do my project. It wasn't really an issue. Performance, availability wasn't something we thought about in the old days. You show up with your media and your skills and you do a Citrix project. Again, as I said, our background came out of early Citrix, more XenApp, and then moved into VDI, where we're now in the business of application and desktop delivery, and all of a sudden storage became critical to everything. On our early projects, it became potential failure points, and we had to jump in. We were kind of forced to learn it and innovate and do some things to make it all work. What we found too is that a lot of our peers and our customers and clients and friends were in the same situation. They didn't really know storage, they never had to, and now they're being faced with performance concerns and customers needing more things, projects possibly failing, and so you get sort of forced to do it. And the concept of this session, especially the early one, was to just kind of give you all the tidbits we've learned as we go. It's pretty basic. It starts off at the basic concepts that we learn the hard way. You're in the field and someone says, fiber channel, what does that mean? How do we deal with it? We had to learn one step at a time. So we took all those chunks and put them into a session, and we think it's going to be very valuable. Anything you guys want to add to that?
Yeah, how many of you guys are like XenApp or doing VDI right now? Any of you guys consultants? Do you guys have to go out to your customers and explain the storage impact every time that they want to do a VDI project? I remember 10 years ago, we didn't really have to have a storage discussion unless they wanted some ultra high density metaframe servers that you had to put in like a platypus card in there, or a JetStream, or some other very expensive local disk in order to bump up the number of concurrent users that server could hold.
Do we have any storage storage experts in here, like SAN people? Oh, we got one. We will offend you.
Yeah, we will offend you. It's kind of like we gave up on the network guys, now we pick on the storage guys. We have a bunch of copies of Storage Area Network for Dummies.
Great reference material for us.
And you can have one if you actually teach us something or correct something or give us some great insight. You'd have very entertaining input, or you just get something so wrong you really need this. So they're available. I think we should go with audience consensus about who decides who deserves one. So we'll figure that out as we go. As you can see from this slide, we became skilled at storage and innovated new ways out of necessity, as I said earlier. But what was also interesting is we would go in and the customer would assure us that their storage is performant, and it wouldn't, and it would be a problem. It would be a project breaker. So we ended up actually replacing a lot of big name arrays and configurations with smaller, nimbler solutions in the field. And what's interesting is our work scope now, as Joe was saying, it now involves storage. We used to just be the virtualization, application consultants. And now we've got to go in and know storage cold. We've got to be able to talk to the SAN guys, the network guys, design it, understand it. And again, we want to take some of those concepts and transfer them. Session 1 is basic, and then you get into Joe's world in session 2, which goes a lot
How many
deeper.
of the engineers or consultants out here have had to explain storage to the storage guys? Has anyone had to do that?
Yeah, so that's also one of the experiences we have is, the storage guys may be more conversant in carving up volumes and capacity, but don't understand really the impacts of IOPS, reads versus writes, the kinds of things we deal with in virtualization.
Even if not going to get to into the storage arena and become the storage guy, and you're still going to ZenApp and VDI and even this virtualization, you need to understand what storage is and how that is going to impact the environment, and even be able to design something that you can even give to your storage guy to be able to fulfill the requirements for your project. As you can see on the slide here, it's kind of something that we kind of use a lot, and you can see everything in here uses some kind of storage. So everything uses storage.
Is there anything on this
not
picture?
Just VDI.
Is there anything on this picture that does not use storage? Can anyone point anything out?
Okay. Yeah.
The
Good catch.
load balancers use storage, and this scalers do at least.
Well, but do you mean like shared or complex storage?
No, but they use it for caching,
Well, yeah, they have flash and they have a hard drive.
logging, flashing,
Well, see, there you go. See, right, even among us, there's a misunderstanding. We say storage. Well, some of us are assuming it's shared and it's on the SAN or iSCSI. Some people are saying storage in general. So there's an example of the confusion among us. I think the point, though, is everything we touch, especially if it becomes virtual, now needs to use some kind of shared storage. And it's not your father's ZenUp anymore. I think I just saw Brad. We've come a long way. These elements use all kinds of storage and have all kinds of different impacts. The support infrastructure, the workloads, VDI versus ZenApp, have storage requirements that can be optimized in different ways with different types of storage, and you have to understand them all.
Yeah, you notice there's on the PVS line there, they've got CIFS and NFS there. Yeah, technically you can use those for your servers and stuff, but please do yourself a favor and don't.
That's a
Please
message from
don't.
Joe. Thank you. All right, as I said, starting off in the old days, and let you take this thread here, Joe, because I know it's near and dear to your heart. But I will start off with the early days where, if you're in application virtualization, you may be doing AppV or presentation server or WinFrame, the early things. You basically show up with your Citrix CDs and you do your project. You ask for servers and disk. You utilize them. You just need the OS and apps. It's pretty simple, and you're dealing with a traditional disk. It's not like that anymore.
So, like in the old days, you just had a server with a disk on it. Now, start virtualization, where is your data? When you have an operating system that has a file format, where does it really exist? In this example with the VMware, we see we have both file level and block level storage. So you have a virtual machine that's got an operating system, most likely Windows, formatted NTFS, but really that NTFS is really a virtual block device presented by VMware or in this case, VMware. But that block is really just another file. Right? The block level device being presented to the virtual machine is really another block level device. It's really a file that resides on top of VMF, another file system. But what is VMFS? Right? VMFS is a file format for a block level storage that thinks it's on top of another block level device, another block level device that's being presented to the host. Well, is that really the block level? Are we still at a block level? No. If you do something like VFS, it's really a file system. So now we've encapsulated block in the file system to block, the file system to finally we get to disk. And when we thought we were done with that, Citrix goes out and acquires PBS, and for the projects that we're doing for VDI and ZenApp, we started introducing a whole other storage architecture with provisioning services. And so now we have vDisks that reside on top of NFS. But those vDisks are streamed, and you can see we have the whole sequence of storage there. Then we start talking into the Citrix vision of breaking things out, right? Now we've got AppV. We've got other services, profiles, and stuff that we have to deal with. So, you know, app V, it's got a file system. If you go to the Q drive is really a jigsaw file system. But that jigsaw file system is really encapsulated into like a block level with the SFT. But that SFT really resides on a file system, NTFS, which resides on a file share. Again, going through, a lot of times, centralized file servers or come from a SAN. So,
As you can see, this is kind of a simplified message for it. I mean, you start getting the waffle system from NetApp, it adds a lot more. You start getting all the different VM types. It grows exponentially. If you start throwing VMs on top of VMs inside a virtual hypervisor, let's say you're running it on Hyper-V and you put that onto a virtual hypervisor, can you imagine how nasty this is going to get for you?
and the thing is, you got to understand the different layers in here too, because if you have a Windows operating system that's trying to optimize itself and take storage and put it out what it thinks is the outer tracks for performance reasons, is it really the outer track of the physical disk that it actually lives on? Or is it the outer track of the virtual disk many layers deep?
And this is the horror, the dirty little secret of VDI. Everyone should just have a VDI machine that they log onto and everything dynamically composes and just in time, and this is all the crap beneath it. And
we got customers that they love DiskKeeper, and I have no idea why. It had a place and a purpose many years ago, but when you look at this, you're just re-randomizing all the blocks again.
So we broke this down to what we think are some keys to understanding storage. You get an appreciation for the complexity involved, and we want to go through basic concepts and terms that help you understand it, understanding blocks, SAN versus NAS, local, etc. And we just wanted to think about maybe go back and see this example, to really think about when you're analyzing storage, designing, or troubleshooting, what layer are you working with? Are you looking at the physical layer? Is it a virtualized volume? Is it block? Is it file? Is it something like, great example with Softricity, is it block stuff in a file, on a file system on block? You have to sort of understand those concepts. So a few guiding principles too is understanding the different features of storage, which we'll try to cover most of them, how they impact performance and cost, and understand the workloads that you're working on. And of course, always start with the organization's needs first. Joe put this comment, which I thought was do the math. Don't assume your expensive array will work. We've seen that countless times. That's what I was referring to early on about project problems and potential failures, where they say, well, we got this expensive array, fill in the 3-letter name, and it's going to work. Why is it going to work? Because we paid a lot for it. That's actually a common problem we see.
You can guess how many IOPS an app user is going to use. You can guess how many a VDI and extrapolate from that. But you already have the data somewhere in your organization. You just have to go collect the data and analyze the data. You might need third-party software to go and help you collect that data. But once you have that data, now you can mine it and you can actually get a true number of what you really need. And on the flip side, when you actually design the storage and bring it in, you need to test the storage to see that it actually delivered what you're expecting it to deliver.
Surprising what it doesn't deliver. And we have a great slide, which is the lies of storage vendors, which we are looking forward to giving. There's some concepts that you have to sort of also look at. They seem obvious, but they're really not clear to most of the people we speak to about the relationship between cost, capacity, and performance. Some of the speakers on this topic say you can't have all three. We also add into that the idea of features impacting performance and cost. Do you want to speak to this?
Yeah, well, it's a couple things. People like deduplication. It seems to be a very popular ideal feature that most requested on a lot of these storage platforms. It has a place, but I don't think it has a place everywhere. But when you dedupe data, you also fragment the file system. You also fragment the blocks that are on the disk. So you're taking all these blocks and you're deduping in one location. Well, now the heads the actuators have to move more, increasing latency and decreasing the amount of IOPS that you can actually pull from the actual performance you can get from that device. Now, something like NetApp, where it's inherently built in, and that's what a waffle file system is. It's everything pretty much randomized. So, but if you're expecting performance on sequential reads, if you do random writes, you're not going to get sequential reads. You know, you're going to get a performance penalty based on that.
Again, some concepts you don't think about until you get burned by it, that sort of thing.
You take
Snapshotting is another example, right?
Snapshotting is another one. And so if you take a snapshot, there's some background I/O that has to happen. If you don't take into account that background I/O that has to happen, you're going to also have a performance impact there too. But
So you take a feature of dedupe, it reduces performance, but it increases, let's say, your capacity. You take snapshotting, you lose tons of capacity, but you increase your availability.
And that's a good example.
Right.
So like dedupe, so now on the flip side of dedupe, you can actually cache more things in the RAM or into a flash SSD or something like that. So you can actually aggregate more data into a flash and access that data a lot faster.
And then with flash and SSD drives, of course, you get better performance, but you
At
less capacity and
Less
higher
capacity
cost.
and more
So
cost.
these are the relationships. This next concept is something just to think about. It's things that make you go hum. Is in researching this, is that what's inside the disk? When I think of my storage, I keep lots of copies of my storage because I've been burned too many times, like my home stuff. I've got 3 or 4 copies, and then I put it out on the internet as well. And I feel like I have something. Except when you think about what storage really is, it's just little bits on a disk. And here's a 200 micrometer view of a magnetic plate. And you're seeing that your precious data is just little blips in magnetic fields. There's a lot of good error correction, but it's interesting to think that all this work we're doing is really about something just kind of virtual that easily can decay. Just something to think about.
Earlier this year, IBM announced that they built a technology that they can get 400 terabytes in a disk, in a standard disk these days. So it's not quite out yet, but when you think about 400 terabytes, they basically got it down to 1 bit is equivalent to 12 atoms. So if you think about it, 12 atoms is the difference between a 0 and a 1 in here.
It's kind of scary.
It's kind of scary.
It already scares me how many drives go bad and how many times you lose data that way. Okay, so now we're going to get into key storage terminology concepts and phrases. And this is somewhat freeform. These are just things that we've learned that we had to understand. We kind of put them out as concepts, phrases, or definitions. And I please encourage you to ask a question or debate or disagree if you think so. But the first thing is just block level. This is actually a concept that is very, very simple. Block versus file, for example, but it pervades everything you do. When you saw our diagram of virtualization, you had to understand at each level. Was it block? Was it file? And that was important. It also changes the kind of devices, commands, language, performance expectations that you're getting. So block is basically addressing the bits on disk. It's usually when you're talking directly to a disk or a RAID set or a virtual set of disks, and you're typically using SCSI commands. Disk commands are involved in that communication. Anything on that? As opposed to file level or file system. Again, when we look at the hierarchy of virtualization, this concept's important in identifying and designing and troubleshooting. Files are obviously when you're talking about things that are composed into logical structures in a file system that's applied to a disk. You're no longer talking block commands, you're asking for a file, you're saving a file, you're updating a file. And
the underlying operating system is doing all the negotiation with the device itself. It's still using block level storage,
right.
But you're adding a layer.
And these concepts, again, come into design, troubleshooting, but also into feature selection, things like deduplication. Now, you're taking the file level example. Network attached storage is file sharing that's made available over the network. Again, there's no instance of block. There's no disk commands. You're not mounting disk volumes. You're putting shares out, typically in CIFS or in NFS. And we obviously know these as appliances like NetApp or just Windows CIF shares.
So basically, you're just remoting the file system from one machine to another or one device to another.
The first remoting, primitive remoting, right? And then, of course, the storage area network, which is block by nature, right? So here's where that distinction starts to play in. With a network attached storage, we're dealing with files. With a storage area network, we've taken disk command protocols and found a way to network them, to put them through an arbitrated or non-arbitrated loop for one application or server or operating system to talk to a disk that is through a network, right? That's the basic concept. Anything you want to add? Did we skip that? Lun, want to take this one?
Yeah, For those that don't know what LUN is, it's a logical unit number that back in the old SCSI days, you had a chain, and in there you would add devices, and each device would have a number, and then you terminate each side of there. And when things started getting larger and started getting to be more more SAN-based, we started going with logical unit numbers to be able to present a block level storage to a device that presented as a LUN number, like LUN 0, LUN 1, LUN 2.
Exactly. You got to break up the storage you're providing into something that identifies that set.
This allowed you to present different types of block level storage from different devices, or even from the same device. You might have a boot off SAN, which is your LUN 0, but then you might have all your data off of another LUN.
And just taking like a hypervisor example, if you're trying to mount storage that's block level, you're going to be mounting a LUN. You're going to find a LUN number that's published that you can use for that disk volume. Okay, this one's interesting. Fiber, F-I-B-E-R versus F-I-B-R-E. This might be a reason to give away a book.
Sure.
Does anyone want to take a shot at why that is? Why they spell it that way? What's that?
One's a cable.
Okay.
The other one's a car.
Okay, that's good. Do you know why, though? Yeah, why that was done that way? To reason to ask question?
It's a confused word.
Well, according to Storage Area Networks for Dummies, they say it was to distinguish it from networking fiber optics. They were trying to make a separation, that when we were talking about storage networking, we would change the name to switch the letters around to jar you that you're talking about storage. That's an interesting point. So what's running over the FIBER if it's fiber channel protocol over Ethernet, or what is it? All right, we'll have to ponder this one. Now Joe took umbrance with something here that I took this out of the references that a 4 gigabit per second fiber channel connection transmits about 400 megabytes of data per second. And my thought in putting it out there was just trying to relate to the audience, what speed of that interface translates to in terms of data moving, forgetting any overhead you might have or latency in the application. And then an 8 gig would equate to about 800 megabytes per second. And that gives you an idea of you kind of know what disks have on them and what they can do and what's involved. But Joe was pointing out that fiber channel is a full duplex protocol. So there's a send and receive strand of fiber, and he says it should be double that. So you want to explain that? And if anybody can prove or disprove this, you definitely will get a book, because especially if I end up right.
Well, it's a full duplex, so basically it's bidirectional traffic. So device 1 can send 400 gigabits to the other device, and device 2 can simultaneously send back that same amount of traffic. So when you think about bidirectional traffic, we essentially have 800 gigabytes full duplex and 1600 megs full duplex.
Okay, you kind of actual storage guy comment either way? Yeah, please.
I have a question on the networking workflow. You go 10 megs, you go 100 megs, you got a gigabit. It's full duplex. It doesn't mean it's double.
Right,
That's correct.
It goes both directions.
exactly.
You don't double the number.
And that's the question.
So you don't double the number because it's full duplex is saying that it's bidirectional. You don't double
You
that.
can double the number of course. That's what full duplex means. You can transmit in both directions at the same time.
I think it's a designation of capacity more than it is throughput, right? You've got a straw that goes up for 1 tablespoon per second.
Okay.
You can't push that both directions. That means that straw can hold 1 tablespoon.
So the total sum of the bidirectional communication is this number. Did you have comment? Because
Well, I just had a comment about comparison of networking and 1 gigabit, for example. But from a storage perspective, I think you don't care about the full duplex part of it. So 99% of deployments, you really care about your maximum throughput in one
Right.
direction. So you care about how fast you can read or how fast you can write. You don't care about how fast you can read and write at the same time.
okay.
I've got something here on page 28 of our lovely handbook here. It says that this is the capability for simultaneous two-way data transmission is known as full duplex. This is a good thing to have because you can transmit and receive data at the same time, which means that things can go twice as fast.
But twice as fast as 400 megabytes per second, or twice as fast as
It does make a difference when you have controllers.
Okay.
It does make a difference if you're doing something like synchronous mirroring, where you have one controller that has a bunch of disks off of it, and you have another controller with another set, and you're synchronously mirroring those volumes between there. You're going to have fiber connections in between, and you're going to have bidirectional traffic between those two controllers at all times.
I think the key to the whole thing is, did the vendors, when they say it's 4 gig, already take into account that they doubled everything?
That's
or
the question.
It's 2 times that.
It's 2 times
It's 2
that?
times?
When they say 4 gig, they're saying that's the signal I can transmit to you at 4 gig. You can also transmit back to me with that. That's what
Okay.
interpretation.
So who gets the book?
Now, what that means, however, is now I've got to have both ends capable of handling that type of traffic.
Right.
Shooting me 4 gig at the same time as receiving 4 gig. CPU, memory, all the other pieces and parts of the hardware have to be able to make use of that, or else you're going to back up on what's actually being transmitted.
I like his answer, but so,
Yeah, you're going to double that.
so it would be double. If the 2 endpoints could handle it, you could do 800 megabytes per second with a 4 gig link. Okay, I say he gets the book. You guys agree?
That's up to the device. Could you
Let's just
actually-
get let's just get an audience consensus. Does he deserve the book? No?
Why?
Why, you do?
Does he already know the answer, that's why?
The one who doesn't understand anything that's going on here. Isn't that the dummies? Yeah.
Well, yeah, but you know, the dummies aren't really well named because they're not really that basic.
So interestingly enough, I got a diversion. The full duplex is the reason FireWire is faster than USB 2.0.
Okay.
Because FireWire is slower on paper, but USB 2.0 is half duplex, so it can't both transmit and receive at once.
And that's why you get those bottlenecks.
Or like regular
Give 'em a
file
book.
copying, FireWire will be faster.
All right, well, thanks for the interaction.
At the end of the day, when the vendor says 4, is it 4 or 8?
That's what I'm
You don't
wondering.
talk
But
about, you really don't talk about in terms of how much bandwidth is when you have a discussion. You generally talk about, hey, I've got 4 gigabit fiber, 8 gigabit fiber. Now when you go and you start doing the math as to how you're going to aggregate your storage arrays up into your controllers, then you start doing the math, and also from the controller to the front end.
I think we should measure it, like Joe is saying, get the equipment and then measure it. And his session will cover that in more detail. Let's move on to some nuts and bolts, just what the interfaces are. We talked about the equipment on both sides. So traditionally, the GBIC, the transceiver for that fiber, has a receive and a transmit. There's a picture of it down there. And it's also being called SFPs now, right?
Mm-hmm.
Your systems that want to consume it, the application servers, have host bus adapters. These are converter cards that are going to have a GBIC on them, as well as the switch or the storage target that you're going to. And typically we see LC connectors. I don't know if that's different in Europe or other places, but wherever we go, those are typically what we're plugging in or receiving a transmit. And typically our customers either use the shortwave type, the 50 micrometer cables with limited distance for inside a data center or somewhat nearby, and then the smaller long wave fiber that can run, several kilometers, what is it, 10 kilometers generally without a repeater. And we see that in customers of ours who have like large campuses or another data center down the street or across town to a small degree. And those are just things that we come across that we get conversant with. Things that are good things to know. You won't be stumped if you're on a project. And then another important concept, because it's all about the high availability and keeping systems live, is multipathing. You want to take this one?
Yeah, so it's not just about connecting the server to your storage array. What happens if something happens in between? It's just the fiber switch goes down. The idea of multipathing is to have multiple paths that the host can actually get to the other device. So if one device gets cut, boom, you go down another route. It also gives us the ability to talk to multiple controllers. With things like Allure, we can actually write to both controllers and actually double the bandwidth. If we have multiple HBAs in our server, we can go down and write to multiple paths, increasing the amount of bandwidth that we have.
I think in practical terms, if you're like me at the time of first learning about this, you need to understand this and plan it into your implementations and your designs. You wouldn't want to put something out that didn't have multiple paths. Yeah.
Good point to note, when you talk about multipath, it's very important that your underlying operating system also affects your ability to multipath as well.
Yeah.
And how you lay out your lines, how whether you stripe and so forth also affects your throughput on multipath as well.
Right. Yeah, great point. You need multipath drivers of some kind, right? So certain vendors have their own. There is a Windows MPIO.
That's just like AIX and Linux, may handle it better than Windows.
Right.
It's got a lot better instead of full core drivers because it can do multiple IOs at the same time. It's still OS Q limit.
Right. See, that's a great point. So you have to be working closely with your provider and getting their software and their best practices.
And EMC and certain providers that are doing this, because what you're trying to do is encapsulate this stuff now and get this out of the OS. They've accomplished this by getting around and providing their own drivers. And generally, when you work with your whoever makes your HBA card with this intellectual and so forth, they'll tell you how many concurrent IOs they can handle.
In a multi, yeah.
So this is just an important point.
Oh, good. Thanks for piping in. And you get something else?
One of the things I'd like to point out, right now, you've got two paths, A and B. You possibly have four paths down there, so depending on how your two controllers
Right.
is working. Even if you only have one cable connected, I didn't know which fiber to use, you may still have a many paths situation going on here.
So yeah, you have 4 paths here, and typically, some places have an ISL. A lot of times we don't do an ISL, so there are only 2 paths here. Some people really want that ISL only for management, so they only have to configure the zone between the 2 switches, and the ISL gives them that ability, and they want to keep that traffic off the ISL, so they zone that out. But, a lot of places don't like to have an ISL here because now you have, if you don't have the ISL, you have 2 separate domains. So if this switch crashes, there's a possibility that because this switch is connected to this one directly, it can crash this switch too. And we've seen that happen where multiple switches have gone down because one had crashed and it caused a domino effect.
You get yourself into a load balancing situation with the controllers on the fan itself. They will change the path, which path they're sending the data down. We've seen it where you end up with essentially the one appears twice
Can you hear him?
to the
Yeah, he's talking about when you get multipath failures that don't fail right, and then you can see 2 paths to the same storage, and things can shut down. And yeah, it's a good point. It's not a perfect science.
Well,
Yeah,
not to mention the multipathing software from the vendors tend to rely on the actual card having the right firmware and driver revision that meets their matrix that they've tested against on what
which
OS
is
you're
Michael's
dealing with.
point. Yep.
And if you mismatch any of those, you could get a lot of communication failures as well.
And also to point out, this is the absolute simplest multipath, and it has an ISL between the switches, but you can break the ISL, zone it out, and have 2 switches on each side, and then have that extra path in each domain.
So basically, if you're going to do high availability, you should test it out too, right? Just don't assume it works. Because there could be a bug in the firmware of the HBA card, a bug in the firmware of the switch. It could be some bug in the software of your controller. There's a lot of different places where things
That's a
can go
great
wrong.
point. We have a practice in our consulting where we call it, like when we're all done, it's called a failure mode analysis, where we think of everything that could go wrong, and we have to be able to yank the cables or pull the power
It is very
plug.
satisfying walking through a data center, just yanking a cable.
It's fun.
Watching everything go
Get
down.
your
and then
aggressions
you go,
out.
oops. Or the other way, everything stays up, and you go, hey, we were right this time. I mean, it is very satisfying.
But we do see, like a couple of you have said, we do see problems with firmware or multipath software where things don't fail right, and then it all goes to hell. And it's very hard to troubleshoot. All right, the next concept is storage virtualization, which it's being bandied around, but it's really important, especially to what we do, because when we said we got rid of some of the big arrays in our customers and went with more nimble solutions, we basically were doing storage virtualization, primarily with products like DataCore, Sand Melody, and Symphony V, and using Xiotech and other things for high performance. Do you want to speak to this one?
Well, does anyone
What do
use
you-
storage virtualization in their environment or recommend it as a consultant?
What do you guys use?
A couple. What do
Really?
you guys
Okay.
use, if I may ask?
We use, the first player in this was a general. So,
Yeah.
I've really seen that technology grow from something I really wasn't pro to growing. So what's really cool about our environment, is I've got hundreds of servers. I don't have HBA in any of our blades. The blades are seriously just network CPU, and it plugs in on ATM backplane. All the HBAs and stuff are done from control plane level. So you get huge reductions in costs.
That's cool.
And all of my IOs is a little bit different. We've been doing this
So you have like storage virtualization almost with like a mid-plane hardware level to it.
I call it virtualized virtual.
Yeah, like I know what you mean by genera. Another.
You said data core, right?
Yeah.
Another data core? All right, you guys, what do you think of it as a virtualization? Do you consider it virtualization, or?
Yeah.
Yeah?
Yeah, I mean, to a degree, it depends on what you're using it for, right? I mean, what it does is give you that abstraction layer that we kind of have from server virtualization.
Right, exactly. That's the key right there.
The key is being able to
Right.
link that into agnostic, other
Right.
cross-platforming, storage in the back end, so you can have, EMC here, and you said put it in an extent or whatever, you can actually replicate and synchronize between them if you want to do that.
Yep.
Right, and then it also has the ability to really, increase your cache from a performance perspective, right? You can load that, with memory in the front end or the tiering and stuff that's nice.
Very good.
Low rate arrays, so
Yep.
really makes a big difference in what you get accomplished.
So I think one of the key concepts you said you're abstracting, right? Just like with Hypervisor, you're abstracting the machine from the hardware it's on. Here you're abstracting the storage from the application or server that's going to consume it, and therefore you can plug in different vendors of storage. You can, stripe across multiple different arrays. You can mirror things together because there's a layer between.
You make sure your storage agnostic, so you can take a NetApp, pipe it through a data core, and if that NetApp is not performing the way you want it, you want to bring in an XIO device, plug in an XIO device, you can do a background migration from the NetApp to the XIO device, and your front-end services didn't even know that happened.
Yeah, we've done that with a number of customers. It's really cool to do a migration of storage by inserting a proxy that's virtual and then changing the storage that's behind it.
And the benefit is, like with XIO, when you go with the ICE platforms, in the beginning, they weren't very feature rich. So you couldn't do things like synchronous mirroring. You couldn't do snapshots. You couldn't do CDP. They have like 1 gig cache on there. So you can pipe this in, and now you've got these additional functionality that you otherwise wouldn't have from the storage vendor, whatever the storage vendor provided. A lot of people have used it for EMC replication because EMC, licensing is very, very expensive. You can do this at a lower cost, so you've got additional options.
Since we're going into data core, which wasn't the plan, I also want to say that what's cool is it's using Windows and Wintel architecture, and it's leveraging the entire server RAM image as cache. And it provides tremendous benefits in accelerating in the storage. Okay, the next concept is thin versus thick provisioning. And that's a pretty appropriate graphic. I can relate to somewhere along that gradient.
Why
This
is
is
the last guy shortest? What are you trying to say?
This is the idea that you can provide an amount of storage to an application or server and give it that amount of storage, right? I want 50 terabytes, and so now we've allocated 50 terabytes on disk, and it's yours. Or we can thin provision it. We can give you the virtual appearance of having that storage, but you haven't consumed it yet. And you consume that storage on demand or according to some other policy. And there's an anecdote I want to add about this. A major university we work with, where their scientific research centers were constantly on the IT department about needing these massive storage sets. They said, we're planning this research project, and there's going to be 175 terabytes within 6 months, and it would force these guys to go out and buy it. By putting in thin provisioning, it was hysterical. We showed them all these huge volumes, and they never used them. It's like the perfect example of thin provisioning. Thin provisioning can be very dangerous, but on a psychological level, it can be very valuable too.
We had another education environment where they decided to do everything thin provisioning because of the same scenario. They thought that was going on. Next thing you know, they were about 75% under what they were supposed to be passing out. So it is a very dangerous situation. Don't fall into it unless you're sure of it.
So some of the benefits of thin provisioning in the context is you provide the operating system or the service that's going to consume the resources so much space, and it starts consuming that space, but it doesn't use all of it. You might give it a terabyte, and you might end up with 300 gigs of data on that volume. You still have 600, 700 gigs left to play with. But when you start doing things like snapshotting and replication and things like that, you only have to deal with 300 gigs of data at that time. Right? So if you have a failure on controller and you bring it up, you don't have to wait for an entire terabyte to replicate across. You only have to deal with 300 gigs.
Hey, you mentioned Disk Keeper before. We've talked in the past about what happens if you try to defragment, like a thin
When you
volume, for example.
defragment something, it pretty much rearranges all the blocks, well, for the most part, rearranges a lot of the blocks on there, and it could potentially hit every block on your storage volume. So if you thin provision and you run Diskkeeper, you could potentially grow that volume to what it was actually allocated to. And in our practice, when we do thin provisioning, because the storage vendors we use, that's what comes out of box, we really can't tweak that. But when we provision a device or a server, and we say we're going to give it a terabyte, it'll be thin provision, but we put a reserve on that. So if it actually does grow, it'll grow up to that terabyte.
I did have a debate with a NetApp guy. Mind you, he was a sales guy, not an engineer. But his debate was that you should defrag your SSD. Does anyone here agree with that? Thank you.
We should send him one of these by airmail.
It took about an hour to explain to him why you don't defrag that, and I was wondering if anyone else out there actually agreed with that statement. He was a sales guy, not an engineer, so don't put it against
Don't have him
NetApp.
install your system. Yeah.
I don't think he is, actually.
The best phrase I've heard about thin provisioning, I'm sorry, what?
Or is he at sales, Best Buy?
No, actually.
He's probably been laid
an
off.
Enterprise NetApp sales guy. I mean, he's supposed to sell the NetApp itself, not the features.
One of the phrases about thin provisioning I wanted to share was Tim Ward. Are you here, Tim? I know you're here.
back there.
Okay, I can't see you. Okay. Think of it as a credit card, right? If you use your credit card and fill it up, you're going to have problems if you can't pay it back. And in Hal's example, everybody asked for all their thin provision volumes at once, and it all went to hell. So it's powerful but dangerous. Use it wisely.
As long as you don't oversubscribe to storage, you're good. You can thin provision and take some of the advantages of thin provisioning. But when you start oversubscribing in a production environment, that becomes very dangerous. And data grows over time. You're expecting to add more and more data. At some point, that storage is going to be consumed.
Let's get from Michael before we go on.
I just want to add, there's two here. I think there's a third one that needs to be added to the slide. I think it's all provisions. While I like thinking then, you're still writing to a file. You're just talking about hypervisor here. So you're only writing to a file with a PHP or the MDK. And there's additional overhead with that. If you have a huge high-performance application, like SQL Server,
Right.
Vision Server, or I/O is extremely critical. I do need, I actually do a line pass-through, an actual raw provision.
Yeah.
So all my data is on the raw line.
Right.
And you can see, the only way to truly get to a virtualization should be about a 6% overhead at its peak. And I've done the I/O performance test, and the only way to really truly get to that 6% overhead is with a raw line. So
Right. See, I think that's a great point. Yeah.
anything works great if your I/O patterns are low. But if you're cranking out a huge amount of I/O, you're better off.
Right.
You go in the hypervisor and expose the wall.
See, I think that's a great point about what we started off by saying about understanding block and raw.
Yeah, but you're going straight down per virtualization drop right to the line. You're not having to go on top of the file system on top of the
You're getting rid of some of those puzzle pieces we showed earlier.
You do lose some management of that line when you do that. You do snapshot.
Right.
Well, that goes back to the cost versus features versus capacity and all
Right.
that other stuff.
Right.
So.
You want performance, you go straight to the device. You talk, disk commands to the device is the
Again, this is
straightest
that
path.
trade-off earlier we talked about, a feature versus a performance, right? Thin provisioning, there's
move
some
this along
overhead
here.
to thin provisioning.
Bunch of geeks.
Thick provisioning, if you want performance, you may want to thick provision the disk, especially if you're doing heavy writes.
Okay, we're going to move on to the next topic in the interest of time. Here's some water if you want. Persistent versus non-persistent desktops. It's an important concept in design, implementation, troubleshooting, performance, and basically sort of like thin and thick provisioning. In persistent, when the machine boots, you run it, you shut it down, the disk is still there. You have a true disk volume, an operating system, all of its storage is there and it exists for real. It could be thin, it could be deduped, but in essence it's persistent. The non-persistent models are where the virtual machine, usually a desktop, really only exists when it's running, and it's kind of spun up in real time. We like to use a lot of Citrix provisioning server, so there isn't really anything on disk in terms of the machine. It's booted over the network, but of course there's swap space. But it's a machine that goes away, and that's important, again, for planning, understanding builds. Anything you guys want to add?
It's like real cheese whiz.
Yeah, that was an interesting debate one day over lunch. Okay. Citrix provisioning services I just made reference to. It replaces booting from a local block device, like usually the traditional image is a PC with its local disk, and you yank it out, and now you boot that drive over the network. Usually from a single image. The gain is that there's a single image that many machines can boot off of, and it changes all the things. It moves what would have gone to the temporary files of the local disk onto a PVS write cache that needs to be dealt with. In production environments for VDI, that's critical. That's a heavy, heavy write load. It has to be understood how to maintain it, how to size it and use it properly. But it's a very, very powerful technology. Tends to get criticized for its complexity, which I agree with, but I have a Joe who can handle that. And, but what it does is allow true single image management in large environments. What else would you like to say about it?
With something like PVS, when you have single image management, you also have to think about what you're going to do with all those writes. So we have a write cache, and we have to, in this particular context, we use PVS and MTS and link clones and all that other fun stuff. But even with those, you got to consider where you're going to put those writes. And so now we're dealing with almost two different storage systems here, not just one anymore. And it might be complex for me, or complex for most people, but our customers have to be able to understand this too. At the end of the day, we might be able to go in and build this and set it up and get it working, but the customer has to take over and manage it.
I think the key takeaway from this is that write cache is predominantly writing, and if it's all virtual, it's this massive write load that has to go somewhere, so you have to plan for it. And some of the techniques we talked about, like storage virtualization, data core, and SSDs help.
Where do you put the write cache? Do you put it on local disk, close to on the hypervisor, or do you put it back on your SAN, or do you put it back on your PVS server? There's a couple different options. Some are a lot better than others.
And don't forget the Atlantis disk bus.
And
Yep. And that's what's important to talk. And when I have PVS problems, I also have a Hobbit for that. Okay.
You might want to mention the PVS support in VDI as well. Because they're working on the site for the desktop.
Yeah, we love PVS to physical, actually for physical XenApp servers. That's something that we debate a lot on our staff, but we deploy it because we love it, because it's just so simple. You're booting the PVS farm off of a single image, you're going right to physical machines. I got something in the back.
We have done that actually quite a bit.
Yeah, it's a really cool tool. I don't think it's that widely used, but it's very powerful. We did it at a college campus where you took all the lab environments, all the lab machines that were just crap, like a 3 or 4 year old image that was just terrible. It was slow and horrible. We made a nice new clean image, switched them over to PVS, Pixie boot. Single image management, hundreds of machines come up and run.
Yeah, and the funny story with that is we were in there working on it, getting it to work, and we sit down, and the gal comes in, she sits down, she turns the computer on, and the first thing she does is she opens up a book, and she just starts reading this like romance novel. I'm like, what's going on here? Why is she reading a book? She just sat in front of the computer. And she read the book for a little bit, and then she logged in, and then she goes back to reading the book. It literally took 4 minutes for the machine to boot up, and another 4 minutes for her to log into the system. So she was sitting for almost 10 minutes before she could actually use the machine.
Yeah, and so the very exact same hardware, I'll let you go next. The very exact same hardware went from minutes to boot to 25, 30 seconds boot and log in just by cleaning up the image and streaming it.
And we've also used PVS to help turn some of the fat clients out there to thin clients.
Yeah.
So we make it a very skinny image, and it just connects directly into XenApp. And I've talked to a few people about turning their web farms into PVS. And you're just looking to change the identity. Say that again?
Yes.
Yes, use
Yeah.
the local disk for the write cache for
And that's one of these
systems.
cool sweet spots, right? You go in, they got all these PCs, they want to virtualize, and so you turn those PCs into thin clients using PVS, which is licensed with your Citrix software, and now they've got the device they already own, single image management, acts like a solid state device, you leverage the hard drive that's already there for the write cache, you're not putting on an expensive SAN or SSD in the back end, and it's beautiful.
And so we have some places where you can't even use the local disk, and so you do have to come up with another storage solution, write it back to PVS or something, to the PVS service, because you might have a business requirement where a local disk either have to be fully encrypted with something like PointSec or have no disk in there at all. And if the customer had a choice, they'd get rid of the PointSec licenses and just put in a thin client that has no disk. But they could still reuse that machine without having to go acquire a new thin clients to do that.
Some of the benefits of using PVS to the desktop out there as well is that even if the hard drive does go bad and you're using the write cache to the local disk, it fails back over the network. So it's not like the system goes down for the user at the end anyways. Yeah.
Yeah, you do have to be really concerned about the network and bottleneck within the network, and specifically the boot store, when you're pushing to say like 500
Yeah,
desktops.
absolutely.
You have
Absolutely.
to have a different
Right.
job than you have in the data center,
Yeah.
but it does work. We have equipment.
And
Yeah.
we have a couple clients that, to go across the WAN, we actually set up PVS servers at the remote site as well to try and
Yeah,
do the
that's an important point. You can't just add it to a busy production network. It has to be dealt with on a network level. It's a great point.
Yeah.
So will this give me cloud?
Yeah, I think you should get a book for that.
Barry set him up.
Did he? Okay. He's like, will this give me cloud?
No,
If you can define cloud, yes. All right. Data mirroring, another important concept. This is something that you'll find in arrays or in a storage virtualization solution. The two basic modes I think that are worth talking about are synchronous and asynchronous. And synchronous would be when you write data to one node, to one set of disks and one controller, you simultaneously write it to another set of disks and controllers so that the write is in physically two places. This is versus having multiple heads against one set of data. It's two sets of data where the write goes to both. When it happens at the same time, that's called synchronous. We do a lot of those designs for our customers because, like with the multipath example, it's got a multipath for your data. If this set of data goes down for any reason, controller, connectivity, spindles, the other set of data is live, and there's essentially no interruption. That's synchronous. But it also can be done asynchronous, because synchronous assumes extremely low latency and high bandwidth between the two nodes. That may not be the case if you're off-site, off-campus, whatever it might be. And asynchronous has the same functionality, but it's taking those writes, queuing them up, and moving them over, not in real time.
yeah. It can try it in real time, or it could be scheduled at night, when bandwidth usage on the line is a little bit lower. There's different things you can do. But keep in mind with asynchronous, you can't just point your server to there and expect it just to consume the data right away, right? Automatically. You still have to have some manual intervention. It's more for disaster recovery, part of the disaster recovery process, that this controller is down and you need to bring those.
Right. And like the example given earlier,
back up.
sometimes things aren't all the way down, and that causes other kinds of problems. Another key concept you hear a lot about, it's a selling point for a lot of vendors, and it works great in some environments and hurts other environments, is deduplication. And I think some of the concepts here that are important is that you can dedupe at different levels. And again, this is why we talk about file versus block, understanding these differences. You can dedupe at the file level. That's where you look at the file contents, size, you hash it out, and say this file is exactly the same file as this. I'm only going to write it once and point to the other file. Now you make one small change in that file, it's a new file at the file level. So file level deduplication is valuable, but it really only works in pretty big chunks at the file level. You can also do this at the block level. So everyone always uses Microsoft Word as an example. So you save a Word file, and it's a file on a file system represented by a set of blocks. You now change one character in that file, only one of the blocks presumably is changed. Your dedupe routine can just write the new block, right? So now you've saved that much. But it's also possible to dedupe at the sub-block level, which is really fascinating because you get into finer granularity. And this would be dependent on the array that you're on. But it's possible basically to look at all of the data you own and see which blocks are written and not write them twice.
So,
One more concept I want to get over, which is that's talking more of like a real time. The other type of dedupe is coming in, let's say, as a batch job and looking at the storage, analyzing it, and then getting rid of the duplications. So there's inline dedupe. It's happening in real time. That's an emerging technology. A number of the small vendors here at BriForum have it. It's really cool, like the way Tagile has it inside their product. Or there's sort of a more, batch job, and they're different by nature.
so just out of curiosity, those that are running PVS in their environment and putting on virtual storage of some kind, are you guys deduping that storage that the vDisks are on, or for your write cache?
Yes.
Yes, why?
Oh, I'm sorry, you said right there.
Yeah, where the write cache is, do you dedupe?
The image.
The image, yes,
The image,
but
yes, the write cache, no.
right.
Okay. See, there's a time to dedupe and a time not to dedupe. My issue is when people dedupe, they just dedupe. Everything gets deduped. And essentially that block of data exists in one location, in one spot, on one disk, one track, one sector. It exists in one place. What happened to that? Then everything, all these snapshots and backups are all linked to the same thing. If something happened to that block or that disk, that chassis, that rack, what happened to that data? It's all gone. Unless you have another backup strategy to copy it somewhere else, like tape or off-site.
Which brings us to continuous data protection, another concept vendors are leading with and trying to make competitive distinctions with. I like to think of this as like TiVo for your data. I've heard that phrase. I think it was a sales guy, but I like it. I think it was good. Instead of having a snapshot in time of your data at some point, you have a continuous sort of journal, like a database journal file, of everything that's been written, and things can be reconstructed at a certain time. So this gives you sort of a rollback. Now, of course, that raises questions with things need consistency like databases and so forth, but it's really cool because if data is lost for some user error reason or some other system problem, you can essentially roll back and say at this point in time, I want to be there. But like you were saying earlier, in the cost, performance, features triad, it's going to have a performance impact, and you need to leave more capacity available to write all this data.
You can mitigate the performance overhead by adding another storage shelf or something that's as good as the storage shelf that you're trying to put CDP against, but that's an additional cost. So again, we added a feature, we minimize the impact, but we also increase the cost.
Right. So like we were saying, you wanted to dedupe your images but not your write cache. There may be certain kinds of data you want us to continuously protect and not others. IOPS. It's interesting that it's input-output operations per second. Do they not want to say IOOPS? Just saying.
I didn't come up with the terminology.
Okay, well this is your baby.
No, not really.
That's pretty much self-explanatory, right? This is the measure.
One of the things when you measure storage, and we'll get into this a little in the second session, but one of the things you hear about a lot is IOPS, how many IOPS something can do. And IOPS is just a way to say at a specific block size, how many IOPS am I getting? How can I compare that to other things like my users are consuming 15 IOPS per second. How can I compare that to what the storage is, what I need on the storage side? Or what is this vendor doing with this vendor? What is this particular technology doing versus this particular technology? This vendor versus this vendor, SSD versus SATA versus SAT, what are the different relationships between writes and reads, and what are you doing?
And in the second session, Joe's going to go a lot deeper and show you measurements with SQL.io and what he did turning cache on and off, and so you can get a lot deeper in that in session 2.
And if you start getting deeper into this, it's very important to start measuring some of this stuff. How much throughput you're getting, how many IOPS you're consuming, and how much you're presenting.
And you'll also explain the impact of block size on throughput, right? Okay, so the next topic, we kind of went over what we think were some key terms. I'm sure there's many others, but we wanted it to be sort of like if you had a gap in some area, oh yeah, okay, that's what that term means, or I understand the connectors, I understand these concepts. The next thing is putting it together and presenting it to a hypervisor, because at this conference, most things are in the context of virtualization and hypervisors. So you take the concepts that we put out there, and you can present storage to a hypervisor as a direct attached, an NFS file system, network-based file system, as block-level iSCSI, block-level fiber channel, or of course like ISOs, like we're used to for doing install media. So each of those have certain characteristics and pros and cons. Did you want to say something? Okay, direct attach, obviously it's storage that you physically attach to the server. It's connected or cabled in some way to the hypervisor instance host itself, and it's seen by the host that it's connected to, but not seen by the rest of the cluster or farm of machines. And it actually we're finding there's a lot of good reasons to do that in production. We've kind of started off wanting to do everything as shared storage, but there's a lot of situations where that makes sense. Like we talked about PVS write cache, there are times when just throw it on local disk. The customer bought way too much disk on every box. Why don't we use it for write cache, for example?
Oh, way too much disk or way too many disks?
Probably too many, both, right?
And then there's a cost factor associated to that. It costs more to, provide stand-based storage to the hypervisor than it does local-based storage.
Exactly.
And the question is, do you really need some of those features that a stand-based storage would provide?
Right. And again, these are sort of some of the real-world things we come up with after going, oh, everything should be shared. Well, should it really? And usually it's because you calculate out what it's going to take and you go, holy crap, customers got to spend $1 million in storage. Why don't we move some things local?
I feel one of the best benefits actually of the direct attached storage is I don't have to deal with a SAN guy, no offense. But let's face it, they're just like the network guy, it's never their fault. Even when you can prove that it is, you always end up butting heads with somebody, whether it's the network or the SAN guy. Again, sorry.
It's the vendors.
Oh,
the vendor's fault.
It's the vendor's fault,
That's
is
it.
where we're getting redirected to this time. But that's one of the best things about using local storage is you do get to avoid bringing someone else in. You get to control the whole thing from start to finish.
Yeah. And like we said, it's adequate performance for many workloads, surprisingly, but certainly not ideal for a lot of workloads. And what are the cons? A server only has so many spindles on it, right? You don't want to start stacking up USB drives, external USB drives outside of it. So there's only so much you can put in, especially in blade servers. It's not shared storage, so you can't put it out to the rest of the cluster, right? It's only that host is going to see it. You lose out on features of the hypervisor as a result of it not being shared. You can't do vMotion or ZenMotion. You lose HA features, DRS, et cetera. So those are limitations. But again, there's lots of workloads that don't need any of those things, so it's an option. You can't, if the machine itself is stored locally, it can't be moved or cloned. It has to be put onto shared storage to do that. And let's move on from the Zen server
You can do some snapshotting and cloning, but again, if it's part of a disaster recovery process, it doesn't do any good if it's on the same volume.
Right, exactly. NFS is very important in virtualization. I think most of you probably already know, because it's a network file system that was established for a long time, pretty well optimized. It provides file shares over the network. And it primarily came out of the Unix and then Linux type environment and became the basis of a lot of popular products like NetApp filers, for example, were based on NFS, and they helped advance the adoption of that. All the hypervisors use it. It is native in Zen Server and VMware, eNesks. And what we're finding, it's increasingly recommended by both Citrix and VMware for heavy workloads because they can sort of get rid of all the disk command, disk contention issues and just throw it off on a network share, do it at the file level, and they seem to sort of put off some of the issues that you get in practice, but that's questionable too. Anything you want to say?
You said all hypervisors.
Oh, not Hyper-V.
Microsoft.
Yeah, except Microsoft. From local storage? I heard about that. Who's that?
It's Nutanix, and
Yeah.
what they do is they actually are doing a similar kind of thing with the storage virtualization layer, where they actually have an appliance on top of the physical hardware that is being presented back at that storage back into the hypervisor layer. So you essentially have shared storage in there, and they're actually replicating something
Right.
across separate nodes inside the chain.
Yeah, I was going to say that.
It is presented back as a shared storage.
Yeah, and it's an example too. It's an example too of everything. Every term we're talking about, somebody's doing a hybrid, right? That breaks the
You can do
rule.
like Shitan in his session yesterday talked about Sheepdog, which is the replicating between Linux machine for KVM. The way to do it, but are you really turning that direct attached storage into a distributed storage array? Are you making it more of a SAN than a direct attached storage at that point?
Okay. And then some of the pros of NFS are that it's network-based, so you have familiar and often less infrastructure involved. It tends to have lower cost, especially if you're doing open source Linux and other things like that. It's pretty simple to use. You just define exports and mount them, and it works pretty well. It's pretty well optimized for the network. As I said earlier, you generally see a higher density of VMs for an NFS share compared to a single block volume, but there's also performance issues and other things involved. And there's very broad vendor support, apparently, except for Microsoft. The cons, the big first pro was that it was network-based.
We forgot one on there too. I mean, I'm a Windows guy, so it's not Windows-based either. Unix, Linux.
Right, so it's not comfortable or familiar to most pure Windows shops, and there aren't necessarily good solutions.
Well, you could use NFS with Windows, but that's just crazy.
Yeah, I mean, it can be done, but
With Unix tools for Windows, I think.
yeah, they're just not that good. I thought it was funny when we created the slide that one of the pros was that it was network-based, and then one of the cons was that it was network-based. So
Dealing with the network guy again.
yeah, you know, it's a benefit that it's a cheap infrastructure that's well understood, but it also could be a problem with contention and other things like that. File level protocols tend to be less efficient, and Michael gave us the example of there's cases where he had to go straight to block, straight to raw disk. You're sharing the Ethernet, so the Ethernet has to be, you know, plenty of capacity and fast and so forth, and then the tough sell for Windows organization. Yeah, I know. Let's go through these quick. You want to take some of this? iSCSI. All right, iSCSI is also block level, but it's a protocol that's designed to work over Ethernet. We'll kind of make this go faster. But again, the concept is it's block. You're presenting disks to a server application that's going to consume them, to an operating system, and that disk is presented over Ethernet. So like NFS is presenting files over Ethernet, iSCSI is presenting block level disk commands over Ethernet.
And again, it's network-based, so you still have to deal with all the networking issues. You know, a lot of these networks have some level of loss inherent into them, and the block level protocols really don't like. They want to have lossless connectivity,
Right.
and fast connectivity between the devices.
We're on the pro slide, not the con slide.
The what?
We're on the pro slide, not the con.
Well, the con is network-based too.
You have to have a very good network infrastructure for iSCSI to work well. If you have a poor network infrastructure, it performs very poorly.
Yeah, because think about this.
dedicated to, you don't want to be sharing
Correct.
data network traffic with your
That's right.
plane traffic.
It needs to be dedicated, highly segmented, lots of
A
bandwidth.
lot of companies go with iSCSI because they don't have the fabric network already, so they're not going to really split out a lot of the network traffic for it either. It costs more money, so you have to have a nice balance between them because they don't want to spend the money for the fabric, but not necessarily want to spend money for more network, so they try and VLAN it out and everything else, so you still run into a lot of contention.
See, I like that point because it can be an illusion. Oh, it's Ethernet. We already have that. Let's do iSCSI. But now you're asking us to do an amount of traffic your network's not designed for. So that's when we like to go. No, you really should use fiber channel. Well, why? Because it's going to cost you a little bit more, but we're not going to be putting this on top of your mess you already have, right? So that's an important practical point.
So is block better than faster than file share? Forget about the network and the traffic and all that stuff.
Right. Well, you can't forget about that because on file level, you're essentially going over the network.
We can put a separate one for
Yeah.
file share, can't we?
I mean, if you wanted an answer, I'm never afraid to take a position. I would say that generally block communications are faster and more efficient, right? But they're generally talking hardware. They're talking an operating system to a piece of hardware. You're not packetizing, you're not dropping packets, you're not using the overhead of TCP, right? So generally, yeah, but now you make it iSCSI, it's block level, but you've put it over TCP,
I
IP.
think the easiest thing is you don't really see many systems booting technically over an NFS. You see them booting usually off of a local storage or some kind of I/O traffic, fiber channel to boot an OS from SAN, and you don't really see too much going over the network for that. So I would say fiber channel is more reliable.
Fiber,
faster.
I'm talking about the block versus
Well,
Right.
block level versus file.
So we have a server connected to
Yeah.
block, nothing in between, nobody's there. Just if we test that versus a block level, iSCSI, and test that, which one would it be faster? File share or?
It depends. You can get into things like 10 gig and faster.
Anybody
networks.
else have any viewpoints on that? He's kind of saying, you know, you line them up equally, is file or block faster? I would say block by the nature
Well,
of
it
the
depends on what your
commands.
storage vendor is. If you take a NetApp, right, NetApp really kind of flips everything on the head. So when you look at NFS storage, their NFS is faster than their iSCSI and their fiber channel. So but in the real world where everybody else plays, fiber channel is usually the fastest. Then you got NFS and iSCSI. iSCSI is generally a poor man SAN for the most part.
Well, when we were setting up our system, we originally had it set up on NFS, and
Which platform are you on? I mean, for the storage.
They're the Netgear radios. They're not real high end, but that's what we had to use.
So in that case, the Netgear performed way better on iSCSI than NFS.
Yeah,
Right.
and you'll see that, you'll see those differences in the
Right.
different vendors. Again, that's why I used the NetApp example. NFS is the fastest, then iSCSI, then Fiber Channel, or you can
Yeah.
break it up either way.
Michael?
But I think it depends on, there's a lot of factors we don't know about here to really answer that question. It depends on,
Right.
are we doing iSCSI hardware, are we doing iSCSI software? One thing we haven't talked about is caching. And NetApp has some proprietary caching algorithm, and caching can dramatically affect SAN performance.
Exactly.
My personal opinion is NFS, like SMB and other things, is another higher level protocol that you have to go through. So I'll come back to Steve's point. Generally, in my opinion, block level would be faster.
Right.
But you do lose some of the
Correct,
complexities.
exactly.
You test it in your environment, you need to test in your environment because the hardware, the firmware, and everything comes into play here, and especially SAN caching. SAN caching can dramatically affect these type of things.
Great, thanks for the input. How much time do we have left? My clock's a little off. 5 minutes? All right. Well, we obviously didn't get through all material, but the interaction was great. Do you want to, let's talk about Fiber Channel, because that's an important concept on our basic concepts. So this is a protocol and an architecture that's designed for storage. So it's fiber optic based, and it's intended to provide high-speed storage. So it is going to be generally faster. You know, if you're just looking for a short answer, it's increasing the speeds from 4 gig to 8 gig and beyond. It's switchable, and we're also seeing the convergence of Fiber Channel over Ethernet, which brings in some other complexity. But here we're talking about sort of traditional Fiber Channel. So the pros are, as I said, fast, low latency, built for storage. It's a separate infrastructure, which is a huge benefit when you're looking at iSCSI and the customer's network already has issues. You don't want to throw this storage traffic on top of it, but it is more expensive, and it's a specialty. It requires HBAs and other more expensive type of gear that has to be integrated, and requires more planning and understanding and other technology. I think because of the lack of time, I'll put the IOPS up and just suggest you go to session 2 where Joe really dives into IOPS deeply and gives you tools for measuring and looking at output. And maybe I'll leave this slide up because I think it's important, as we started with, the complexity of the layers in VDI, and then open up to any other questions or discussion that you have. Any questions? Yeah.
Well, Microsoft apparently lets you use file share for
Virtual machines or for clustering?
right.
Yeah.
Yeah, that'd be pretty much a
Speak in the
majority,
mic. Speak in the mic.
majority node cluster, and it uses a file share to sync back and forth. It's faking having a shared volume. It's keeping a replicated copy of it local on both disks and having to synchronize it, hopefully real time.
No, my point was, then we get back to iSCSI. That's faster or still iSCSI?
When you're dealing with like a Microsoft cluster, it all depends on what you're trying to do. I mean, majority node clusters are a beast in themselves. If you're talking the file share, you have to have more than 2 nodes of it up, and then they all replicate through the file share. If you want to do just 2, you'd have to go with iSCSI and do a shared storage. But then again, it all depends on what you're trying to do with your cluster. I mean,
Okay, well, let's just end the session. We're happy to talk a little bit afterwards. There's plenty of time during the break. Thank you very much for coming. We appreciate your participation.
Hey, Ahmed, can I have a book?
Yeah. You can.